Morning class. Last period we talked about electromagnetic induction. Today we want to remind us of something we've also done, which is mutual induction. Our objectives are this concept of mutual induction, the transformer, energy loss in transformer, then transmission of power over long distance. We'll start with concept of mutual induction. Let's look at these two coils here. We have the first coil we call the primary coil, and then this second coil we call the secondary coil. The first coil is connected to an AC source, while the second coil is connected to a galvanometer. Don't forget the function of the galvanometer is to detect current or voltage. Now, when the power is switched on, turned on here, electric current flows through this coil. As current flows through the coil, magnetic field is generated around the coil. Magnetic field is generated around the coil. Now, this magnetic field moves down to this other coil and cuts this other coil. And for that reason, current is induced in this coil. Don't forget we talked about electromagnetic induction the last time. We said it is when magnetic field cuts a coil, current will be induced in that coil. Now, in this one, we discovered that the magnetic field produced in the first coil, okay, is cutting through the second coil, we call the secondary coil, and for that reason, electricity is generated in the secondary coil. So we call this mutual induction. Okay, mutual induction, electric current or voltage induced in a coil due to a changing current or voltage in a neighboring coil. Now, don't forget, we mentioned something about the AC and the DC before. Now, we use AC here and not DC because we need magnetic field to change consistently. Now, here in the AC current generates, alternating current, it generates an alternating magnetic field. And that alternating magnetic field is what cuts this coil, that makes current to be induced in this coil. If a DC is used, the DC will only move through the coil once and it will not move backward. And for that reason, current will just be induced once and the galvanometer will return back to its original position. Now, increasing the induced current, how do we increase the current induced in this coil? Now, one, we can bring the coils close to each other. If you bring the coil close to each other, you discover that the magnetic field produced here, many of them will be able to get to this coil. Secondly, we can put a soft magnet in between them. Just put soft magnet to attach these two coils together. The soft magnet boosts magnetic field that is produced. Thirdly, we can increase the electric current that enters into this first coil so that a greater magnetic field can be generated. Fourthly, we can increase the number of coils here. Now, this is the transformer. There are several applications of mutual induction. One of the applications, which is the most common application, is in the transformer. Look at this diagram of transformer here. You get this in almost all your electrical appliances. We also have large transformer used by our electric power authorities. Okay. Now, this is the diagram of the transformer. We have what we call the step-up transformer and the step-down transformer. In the step-up transformer boosts current. It steps it up. It takes a low current, makes it high. While the step-down transformer brings down a low current, brings it down. And how do you know a step-up and a step-down transformer? If you check the transformer, when the number of turns here is smaller than the number of turns here, that is the step-down transformer. But when the number of turns here is more than the number of turns here, we call that a step-up transformer. This is the equation that connects them together. Number of secondary turns or number of primary turns equals to secondary voltage by primary voltage. Now, I want to look at heat energy loss in a transformer. Energy loss in a transformer, there are different ways in which energy can be lost in a transformer. Maybe due to poor design. Now, the first one we say due to heat due to coil resistance. Now, take note, anytime current flows through a coil, the coil gives resistance to the flow of current. For that reason, heat is being generated. You can correct that by using what? Low resistance wire. Now, due to eddy current, you can correct that using laminated soft iron. I will talk about laminated soft iron. Then you can also, it's also due to leak of magnetic field. Now, when the two coils are far apart, magnetic field does not get from the first one to the second one. But I want to actually speak on this laminated soft iron coil. If you look at the transformer before we looked, you just see, I see there's one rectangular metal there. This is a whole coil. This is a solid a solid block. Okay, we use laminated. Laminated means the ions we use, they are in sheet forms like that, sheet forms and then binded together. That one reduces eddy current. Now, lastly, we talk about transmission of electric power over long distance. Okay, how do we transmit power over long distance in electricity? In transmission of electric power over long distance. Now, how do we transmit power over long distance? We transmit power using high voltage and low current. Okay, why do we do that? To reduce heat loss. If you look at this formula, I squared is equals to I. If you take note, we have I squared R there. This I means electric current passing through a coil with resistance R. Power will always be lost in form of what? Heat. To reduce that loss of power, we transmit with high voltage and low current. Thank you very much. By God's grace, we will see you in the Google class. Thank you.